remember from the exponents when you watched the video yesterday? What kind of things did you remember from 7th grade?
Exponents cause me pain.
Okay. Anything else? You guys did watch the video, right?
Yeah.
Mm-hmm. Anything jumping out of your memory? Like, oh yeah, I remember my 7th grade teacher said this kind of.
X to the power of 0 equals 1.
It does, and we'll talk about why that is. I'll show you some math magic.
And x to a negative value is like equal to a flip fraction.
Exactly. Yep, you have to write it. I'll show you exactly why that is too. Good, Bryce. Okay, all right. Well, we'll move on because this is in the recording. So we're gonna review all of these things and then build, and we're gonna do extreme exponents at the end. It's really exciting. So let me put my screen up here so you guys can see it as well. Go ahead and put today's date. Tuesday, February 9th. Right? Exciting stuff. So these first property, these different properties here, the rules, this should be review from 7th grade. I realize for some of you it's not because things got a little wonky at the end of 7th grade. I don't know what your teachers covered and didn't. So most of this should be review, and then we're going to take it up to the algebra level on the back page. Okay, so product of powers. Our example we're going to use is 4 to the 6th times 4 to the 3rd. Who can tell me what my answer will be? Who remembers what we do when we are multiplying? They have the same base. What do I do with those exponents? What do you think? Nathan?
You add the exponents together.
Yep.
4 ninths.
4 to the 9th. Yep. We add the exponents. And there's a catch. You can only add the exponents if the what are the same. The base is the same. So these are all shortcuts, but they only work if you have the same base. So that's product. So really what we did is a shortcut of 4 times 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 4. So we know we have 9 of them, so we don't have to write all that out. We can just do the shortcut. 6 plus 3, I have 4 to the 9th power. So then the quotient if I'm dividing, what do I do, Katie? I'm going to subtract those. So my answer is going to be 4 to the 3rd power. Again, you have to have the same base, which makes sense because multiplication is repeated addition, right? So we added them, and then division is repeated subtraction. So we subtract them, yeah? Is this fond memories from 7th grade? Yeah? Okay, power of power. 4 to the 6th power raised to the 3rd power. Okay, what do I do here? I do multiply. Did you know that, Ava? Yeah, I'm going to multiply them. Because really what this is saying is 4 to the 6th times 4 to the 6th times 4 to the 6th. And I would just add those, right? But what's the shortcut for addition? Multiplication. Right? All right, how are we feeling? Easy? Okay, zero exponent, right? We just talked briefly about this. If I have 4 to the 0 power, it's always going to equal 1. Any value to the 0 power will equal 1. Always. No exceptions. You have that 0 power, always going to be 1. I'm going to prove to you guys, show you how that is. It's very easy to remember the rule, but it's kind of fun to know where the rule came from. You guys ready?
Sure.
Okay, so don't put this on your paper. This is just for me to show you. All right. What is 3 divided by 3? 1, right? Because anything divided by itself is 1. Okay. What is 11 divided by 11? 1. Great. So we get it. We're all on board with this. Okay. What if I had 3 to the 7th power divided by 3 to the 7th power? What would my answer be? 1, because it's being divided by itself, right? Okay, so then we just talked about when we have quotient of powers, what do we do to the exponents? Subtract them. So if I subtracted these, I'm going to get 3 to the 0 power, which equals 1. Okay, whew, that was a little intense there. Okay, so really, when we get to this point of a term, it means it came from something that looked like this, where I subtracted and I got 0 as my exponent. So that's why anything to the 0 power equals 1, because it means it started out as a fraction where the numerator and the denominator were the same. Cool?
Interesting.
Yeah? See? Sometimes it's fun to know behind the rules. Okay, let's move on. Negative exponents. Equally exciting. So we're going to have an example. Actually, we're going to have 2 examples here. So let's make that plural. Examples. 2 to the negative 6. Can't have a negative exponent, people. You just can't. It's not mathematically accurate. I mean, we can write it. Clearly, nothing happened to me when I wrote those numbers, but it's not mathematically okay. So we have to transform it into a fraction where I move this to the denominator, and ta-da, my exponent is now positive. Okay? So we are making it mathematically acceptable by changing it and moving it. So now I'm going to show you guys, again, mathematically, how this works. Okay, are you ready? Is that a yes? Yeah, okay. So if I use my calculator, and I do 2 to the negative 6, I get this cute decimal, right? Because what it's doing is it's making it, instead of making it exponentially bigger, it's making it exponentially smaller, right? Okay, so memorize this number, 0.15625. Got it? If I do 1 divided by, and 2 to the 6th power is 2, 4, 8, 16, 32, 64. I get the same value. Did you see what happened there? So 1 over 2 to the positive 6th power is equivalent to 2 to the negative 6th power. You're just not allowed to leave it as that. You can't have negative exponents. So we had to transform it into something that will make all of the math people happy. So that transformation was rewriting it as this fraction instead. Okay, so let's do our other example. What if I have 1 over 5 to the negative 2? What do you think I'm going to have to do to transform that? Because I can't have a negative. It's just going to be 5 squared. So I change it, I move it to the numerator, put it over 1 just so I can see that process, and so really I get 5 squared. Okay. Does everybody want to see how that works? Sure? Okay, similar situation. Well, what's 5 squared?
25.
We all know it's 25, so I don't need to show you that one.
Good grade.
So if I have 1 divided by 5 to the negative 2, I get 25. You guys, it's math, right? I see all those it's science things around. I feel like we need ones that say, like, it's math. Do you guys know what I'm talking about?
Magic.
Like, have you guys seen those shirts that are like, it's science? Like, proving that science is important? Maybe we need one that says it's math. Would you buy one?
If it's priced semi.
Ben's like, get me on the wait list. Okay, so there's that. Let's move on to our next page. Power of a product. Now, some people yesterday wanted to be like, Mrs. Marsh, you could just do this and this first, and I get that, but we're not gonna simplify early because I don't want you guys to do that in your work. So I don't want you to have a bad habit. So power of a product. So if I have some terms raised to the 5th power. Are you okay, Katie?
Yeah, I'm fine.
Okay.
I'm not even really messed up. Oh.
It's okay. We'll figure it out. We'll get it. Look, it looks like they're all in order. You just need to flip them over. Like they didn't come out of order. They're just, yeah, I think you can just kind of flip them over and put them right back in there. Or if they're in order, like if that's the way they're supposed to go, because it looks like your mixtures packet is towards the back, then you can just pick it up and put it right back in your binder the way it was. Ish. Okay, you work on that. We're going to move on. Or you can leave it like that for a minute while we move on. It's your choice. All right, so what I have to do here, if I have terms raised to a power, I have to distribute into the terms. So really this is going to be 3 to the 5th power times x to the 5th power. It gets distributed to both terms. What if this was 3 squared? What would my exponent be now over here? 3 to the 10th power. Remember, there's always a secret 1 here, so that's like saying 5 times 1 and 5 times 1. Okay, power of a quotient is similar.
Can you have a decimal exponent?
We're not going to, but yes, it's possible.
Okay.
But that's not something we're going to work on today or this year. So I've got 3 squared over x. The whole thing is raised to the 5th power. I'm going to do the same thing. I'm going to distribute 5 times 2 and 5 times that secret 1 there. So I'm going to get 3 to the 10th. Oops, that looks like a 16. Over x to the 5th. Can I do anything with this 10 and 5? What's the rule if I want to do all those shortcuts? You have to have the same base, so I can't do anything. It just is what it is. 3 to the 10th over x to the 5th. We don't know what x is, so we can't just start subtracting exponents because they might not be the same value. All right, let's do some practice. Let's apply all this wisdom we just gleaned here. -7 to the 0 power. 1. Oh, you guys, good. Five to the negative 4th power.
1/5.
Great. What if I said your answer can't have exponents? What would you have to do with that 5 to the 4th power? 5 times 5 times 5 times 5, and you'd get 625. Yeah. Okay. 2 to the 4th divided by 2 to the negative 3rd.
2 to the 7th.
What?
2 to the 7th.
Perfect. How did Atlee get 2 to the 7th when your mind they were thinking it should just be 1? How'd she get 2 to the 7th?
Because the -1 is on the bottom.
Kind of. Olivia M?
Because when she subtracted the
Right, minus a negative is adding. Right? I have had students say, well, I would move this up to the numerator, so then I would add 4 plus 3 and get 7. And that's fine. My advice to you when we're doing our extreme exponents is save the flip-flopping for the very last step. Do all your adding and subtracting, make sure everything gets where it needs to go, and then do your flip-flopping. Okay. Katie, how's it working out?
Kind of good.
Kind of good. Okay, so
Not completely bad.
okay, good. Glad to hear it. All right, now we have another example. X to the 4th times x to the 8th divided by x to the 15th. What should I do, Ben?
Add the exponents on the top and then subtract.
Yep, I'm going to simplify my numerator. Then I'm going to subtract. I'm going to get x to the negative 3. Bryce?
1 over x to the 3rd.
Equals 1 over x to the 3rd, and that will be my final answer. Let's go ahead and actually put little borders around all of our final answers so they stand out on our paper. Okay, one more example here.
Getting some fancy variables here.
Yep. I'm making them up as I go. Katie Williams, what should I do first?
Oh, me?
Yep.
Oh, I think you know. You should add the exponents. Or no.
I'm going to multiply these, right, because it's power to a power, because that's like saying m to the 5th negative 2 times, which is weird. So we'll take care of that. And then I have m to the 8th. It's going to be yeah, we just subtract them. So what's negative 10 minus 8? Negative 18, which I now know should be 1 over m to the 18th. Okay. Are you guys ready for extreme exponents? I wasn't kidding. Look at the next page. It's called extreme exponents.
I'm hungry.
We're close. You got 13 minutes to lunch.
Oh my god.
What?
Oh yeah, wait, we wrote this seven.
What just happened?
It says hora de comer.
Es hora de comer.
What's that?
It's time to eat. There's some guy, he makes really weird Spanish videos. Like, he's like, ¿Dónde vives? And then he laughs, and then he's like, where do you live?
It's like he's acting like he's insane.
Yeah.
Okay, but you're learning Spanish.
Yeah. It's
So-
exactly, yeah.
Does Mrs. Cooper know about this guy?
Probably.
Can you
Oh.
show the other page again?
I am actually going to give you my packet when I'm done. So just, how about you go on to extreme exponents, and then you can have this one at the end, and you can just, is that okay?
Yeah.
Yeah, all right. Okay, here we go. We're going to add in some coefficients. My at-home viewers can't see that, neither could you. There we go. 3x to the 7th times 4x to the 5th. So exciting. You want to take a guess, Ben?
Yes. Wouldn't you distribute the exponents to both 4 and x and 3 and x?
I would if there had been parentheses, but there's no parentheses. So really all I have to do is take this term times this term. So I'm going to multiply my coefficients, and I'm going to get 3 times 4 is 12. Pretty easy. And then I'm going to tack the exponents, and I'm going to get x to the 12th. Because I can combine those. 12x to the 12th. But I like the way you were thinking, Ben. Just we didn't have if we had parentheses, you would have been exactly right. That would have been really extreme. Extreme. Okay, let's do the second one. 3x squared y to the 4th. So this is what you're thinking about here, Ben. Times 2x to the 3rd y to the 7th. Extreme exponents. Oh, what should I do first, Ava?
Distribute.
Yeah, I'm going to distribute this 4 to all of these values inside here. So I'm going to get 3 to the 4th, x to the 8th, y to the 4th, times 2x to the 3rd, y to the 7th. I can't do anything with that yet. Okay, so this is something we haven't seen yet. I can't do 3 times 2 because 3 has an exponent. So I have to actually put this into a value without the exponent. So 3 to the 4th, I'll tell you, is 81. X to the 8th, y to the 4th, times 2x to the 3rd, y to the 7th. So I took this 3 to the 4th and I changed it into 81. Now, even though it's a little bit more complex, this is very similar to our first example. So I'm going to multiply 81 times 2, and I'm going to get 162. Then I'm going to do x to the 8th and x to the 3rd, and I'm going to get x to the 11th. And then I'm going to do y to the 4th and y to the 7th, and I'm going to get y to the 11th as well.
162 x to the 11th, y to the 11th.
Yep. Big number.
Large.
Very large valued number. You guys are taking this way better than my other classes did yesterday. They were extremely distraught about extreme exponents.
I am, but I'm very good at hiding it.
Okay, thank you. Appreciate that. Yes, Ava.
Will we be working with these extreme exponents later?
Uh-huh.
Great.
So I'm not having you guys do an extreme exponent assignment at home tomorrow because I don't want you to I don't want you to hate me. So tomorrow you're doing housekeeping where you're going to update your table of contents.
Oh no, that's
I posted a picture, you copy it. That's really all it is.
good.
Yes.
So we don't have to go through and look at it ourselves.
No. I spent time this morning updating all of my table of contents for my West house and my Miller house, so 4 total binders. And I posted pictures. And then when you guys come in on Thursday, we'll do more exponents together because that's just the best way to do it. Okay. All right, let's go ahead and try extreme exponent number 3. we have 15 m to the third n to the fourth, all raised to the second power, divided by 5 squared m squared n. All right, so my first plan of attack is I'm going to distribute this 2 up here. So I'm going to have 15 squared m to the 6th n to the 8th, all divided by 5 squared m squared n. I can't do anything with the 15 squared or 5 squared because they are squared values. So I'm going to change those into their real values. 225 m to the 6th n to the 8th divided by 25 m squared n. So what I now have is basically 3 division problems. I have my coefficients that I can nicely divide, and then I follow my division rules for my exponent values. So 225 divided by 25 is 9. M to the 6th divided by m squared is m to the 4th. And n to the 8th divided by n to the 1st, remember there's a secret 1, I get n to the 7th. And that's my answer. Yeah?
This is too complicated for my 3 brain cells.
There's a lot of rules, but like you just kind of follow the same ones each time. Like you look for this, oh, I did that, and then you look for this, and it's kind of like learning long division. Remember when you guys thought that was going to be really hard?
No.
You
I
did.
still think it's hard. I don't know how to do it still.
Long division?
I don't know how to do any division.
Okay, we'll have to work on that.
Yeah.
Okay, maybe we'll have a day where it's like, what are you supposed to know, but you're like, I don't really know this yet.
A lot.
What? Math-wise?
Yeah. Why doggos are so nice.
What?
Why doggos are so nice.
I don't know what you're saying.
I should know why, but I don't.
Why what are nice?
Dogs.
Dogs.
Doggo.
Like,
Doggos. D-O-G-G-O.
Yeah, it's basically like a cute form of dog.
oh, okay.
Basically everything in English.
I can't help you there.
I don't know.
I don't teach English. I've got 4th and 5th grade experience teaching English, but I don't think it's going to help you in 8th grade.
Yeah, probably not.
Probably not. Okay, a couple more examples. We might not get to number 6, and that's okay. We've got 3x squared times y squared over 2x to the negative 1 times 4x squared y. So the first thing I'm going to do is I'm going to simplify the denominator. I'm going to multiply and combine all these things where I can. So my numerator is going to stay the same. 3x squared y squared. I guess I can get rid of that multiplication symbol. And then 2 times 4 is 8. X to the negative 1 plus 2 is going to be x, and then I just have the y. Can I simplify 3/8? Does anything go into 3 and 8 evenly?
No.
Oh, so those have to
1.
stay. And then if I do this x section, how many x's will I have in my numerator? 1. What about the y's? 1. So there's my answer. 3xy over 8. Kind of awkward, but that's the answer. Seems like there should be more, but there's not. That's it. Last example. 1 over x to the negative 4, y to the negative 9. I just flip it and make the exponents positive. So I have x to the 4th, y to the 9th over 1. Or I could just say x to the 4th, y to the 9th. Okay, we'll stop there. Everybody feeling okay-ish?
Mostly.
Awesome. Thank you, guys.